Hello, my name is Stefano Masini, and I work for Balsamic, which is a company you may have heard of if you do some prototyping, because we do prototyping of user interfaces. And as part of my job in the last year has been working on a lot of React, because I've been rewriting part of our online application, and we're in the process of porting everything to React. So I gathered a lot of experience in what it means to write real React applications. I gave a talk about React, the basics of React several months ago, and then I gave another talk about Flux, but again, the basics of Flux. And this talk is about state management, which basically means when you start, being familiar with what React means, and you know how to, manipulate the DOM, because you actually don't manipulate the DOM, and so you start building real stuff, then you figure out that you have this little thing that's called the state that needs to be, stored somewhere, and you start asking yourself questions. And so, I'm going to tell you a story of part of the things that I've learned. Hopefully, you will find it interesting. So, first of all, how many of you haven't used React? This question has been asked already, but all of you have used React already. Oh, you haven't used? Okay, good. And who haven't used Flux yet? And just okay, that's interesting. So let me just give a quick recap of what Flux looks like. This is the typical diagram that is used for explaining Flux. So basically, you have your view, and from view you fire actions in response of user events. And these actions find their way to a dispatcher, which is a single thing in your application that is a publish-subscribe mechanism, and floats all your application with these actions. And the stores are the things that listen to the actions, and they actually receive everything, and they filter through the kind of actions that they're interested in, and they do something in response to those actions. So they change their internal state. Once they change their internal state, then they fire events. So it's, there's a difference between an event and an action. And views listen to events, so they can re-render themselves. So the last question for you tonight: who is not familiar with the concept of the difference between events and action? Good. All right. So that's the end of it. And I don't particularly like this diagram, because it doesn't say although it's it depicts a good describes quite well the way Flux is implemented internally. It doesn't say much about how you should structure your application, and in particular, where's the server API plugging into, and then what are these actions? Are they code or are they data? So I don't particularly like this one. So what I'm going to talk about, as I quickly mentioned, is I'm going to talk about components with internal state and managed components. So a managed component is a component that's mainly driven by changing props from the container component. And then I'll talk about having the state stored outside of the components, and that's exactly what the Flux store is for, storing a state outside of the component. And then I'll talk about how to implement server interaction and with the API route. So, and I'll do this through an example. So I'll talk about a dialog. So a dialog, very simple thing that pops in your face when something happens. And it's got a very simple piece of state within, which is a Boolean true-false for visibility. Either it's visible or it's not visible. So once you want to implement that, where do you store this Boolean value? So one case could be, let's store it inside a component. So let's create a dialog component with an internal state with visible true or visible. Right. If we do this, then what we get for free is basically that the parent component can always render the dialog, because then it will be the dialog that will display itself or not, depending on the state of that variable. So if it's false, then the dialog will have in its render method will have if not self state visible, then return null. Otherwise, we'll just go ahead and render everything. So this is good. What's also good, almost for free, is dismissing the dialog. So when you click on the cancel button, you just need to hook that link to a set state visible false, and that does the trick. It triggers a re-rendering of the dialog, and it will disappear. So this is also good. What's not good is that actually showing the dialog requires some other external component somehow reach into this component and call the set state from outside, which is considered a bad practice because it means that you need to know from outside the internals of the state of a component. So that's bad. You don't want to do that. So that was not a good idea. So let's try to put the state in the parent container instead. So what if we say, you save the visible boolean in the parent component. Now, showing the dialog just becomes a matter of rendering it. So the parent component can check on this boolean value and decide whether to render it or not. So again, an if statement, just one level up in a different component. So that's good. Now, dismissing is a little trickier because then the dialog cannot dismiss himself like it was doing before. And so we will have to pass down a property, a callback, from the parent component that will probably call onDismiss, and it's going to be a function. So the dialog will hook that function to the click of the cancel button, and therefore the function will probably call set state display false, visible false on the parent, and that will do the trick. But still, it's it's not the perfect solution. I mean, this is totally fine. So having a relationship with of a component with its parent, its direct parent, is still very good, and indeed, it's a good practice for having high reusability of components, because you can have what they call a UI component, a pure UI component, that's the child, and it does basically, it's totally managed component via props, and it does everything it needs to do within. And then you wrap it with a parent component that passes down callbacks if it needs to. But then the interesting stuff happens in the parent component, but that's it. So that's you don't want to pass these callback functions higher up in the chain. That's the only situation where you're allowed to do this in sort of a clean way. So, but I haven't told you anything about what this dialog actually does. Is there an OK button at all in this dialog? So this is the dialog I was thinking about. So it's you don't have to see in the detail. It's just a form dialog. So this is the dialog that appears when you click on our forms in the products where we have a subscription. Then you may want to change your billing details, your user details. So you click a button on change the details, and you get this form. So this form is in a dialog, and you got a first name, last name, email, whatever have you, and then dismiss dialog across up in the corner, and then a save change, right? So let's see what happens when you click the save change. What are the steps? So the user clicks save changes, and then a spinner shows up. I want to show a spinner. And then the network request is fired, and then the server eventually responds, and it's going to be an OK, in which case the dialog is dismissed, and then the rest of the UI is updated. Or it gets an error. In that case, the dialog stays, but then I want to remove the spinner, and then I want to show an error message. So basically, this is all non-trivial stuff, and this component already starts to become a little complex. It needs to know how to do a lot of stuff. Specifically, it needs to know how to build the data structure that the network request will eventually need. So, you're filling in the information like your first name, last name. That stuff needs necessarily to stay inside the state component, the component of the state of this component. So it will be the responsibility of this component to at least fetch that information and then package it up into a dictionary and hand it off to someone else, right? So a form dialog of this kind necessarily has to have some internal state. But then we just saw that another part of the state, which is the visibility, is better not stay inside. So there's a little tension, So there's some state that is good to have inside, and there's another state that's good to have outside. So where should this state live? Wouldn't it be nice to have a thing that's external to both components that keeps the state, all the state, So this thing here would be, a thing to which someone would eventually send a message saying, show dialog, and then it would flip the bit inside. And then the same thing is the thing that the parent component is going to ask, is dialog shown? Like, should I render this component? And then, if the dialog is actually rendered, then the dialog will be able to call dismiss dialog when the cancel button is hit, or click or call save changes when the save changes is clicked. And it's going to ask, dialog is going to ask the external thing, like, is processing, so should I show a spinner, or is there an error, should I show an error message? This is the kind of things that we want to ask to this. Now, this external thing, of course, is a flux store, and the whole flux architecture is built around the concept of being able to express logic in this way, so that we can externalize the state from components. Yes. They're all the client. We're all talking about the client. Actually, there are isomorphic applications, like someone was mentioning before, where the same code can run both in the server and in the client. And so this would also apply to the server, but this is irrelevant to the kind of discussion that we're having. So, now, let's make the same example. This goes through the same example with a different diagram, where I actually want to show the actual parts of the system. And the UI are the React components, and then we have the store, which is this thing that you get in Flux, where you can actually store information. It's just a simple. I mean, don't think about store of anything complex. I mean, people can build their own stores, and indeed they do. I did. So it's not like you download Flux and you get this store thing that you have to instantiate. You can actually build your own class and fill it up with information, and that's perfectly legit store. So it's an object. For all purposes, it's just a plain good old object. But this is where you keep your information. And so the first thing that's going to happen is that someone will have to click on the edit details. And so this will generate an action. And I've already told you that the actions are things that are able to, about that. So show dialog true is going to be the action that the store is going to listen to, and therefore it will flip the switch and will raise an event. So the event, the store change, goes this way, and the UI listens to it, therefore renders, and now the dialog is shown. Now the dialog is shown, and therefore, the component asks, oh, is dialog shown? Now it's shown. And then the dialog is displayed, and therefore it's going to ask the store, is processing, like, should I show a spinner? And it's going to be a no in this case. Or is there an error? It's going to be a no because we just showed it up. Now, someone will eventually click the save changes, and this is going to be another event. But this time, and this is where the interesting stuff comes up, it's not the store that's going to listen to that event, but to that action, but it's going to be what I call an API adapter. It's also called action creators. Now, there's this weird thing going on about action creators. If you look in the documentation, it's not very clear what an action creator is, and it's not very clear what an action is either, in my opinion. So basically, let me give you my interpretation. An action is just payload. Action is just a piece of data. It's a very simple thing that contains whatever you pass, the name of the action and whatever you pass in parentheses to be clear. And an action creator, which I like to call API adapter better, is something that receives this action and does things in response, exactly like store. So also store is something that receives an action and does something in response. But it's important that they are separate because they have separate roles. And the role of the API adapter is to first of all, set processing bit to true by raising another action. So the API adapter will respond to this action by raising another action. It's totally fine. And then the store will in turn, flip its bit internally. But it will also, the API adapter, actually finally fire this AJAX call. This is what we're looking for. Like, where in the system is the place where you fire AJAX call? This is the API adapter. You don't want to fire them from the store. So this is the thing. And now the AJAX call will eventually come back with a response. And so the API adapter will call set processing to false because then we want to take away the spinner. And we'll also set the error. So this is it. Basically, this is an implementation of the Flux architecture, because a Flux architecture is basically anything that any architecture where you have components that are able to listen to events, pretty much. But the way you want to structure it is that you want to have a portion that is a UI, just the React components. You want to have a portion that is your stores, where you keep the state. And you want to keep this portion as stupid as possible. You don't want to put any logic in there except for logic that is synchronous, and that logic that only works on data that is actually set from outside. And you want to keep the network logic in a different part of your system. And the reason why I like to call it adapter is that because adapter is the name that came up, 2005 Coburn when he was talking about the hexagonal architecture. So it's a design pattern, old stuff, but I like the name. I think it's more explicable of what it does. It's basically adapting your application to the specific type of networking you want to do. So let's say that today you want to use jQuery for doing the Ajax call. If you wrap your jQuery code inside this portion, then tomorrow you can change it and use maybe super agent, and you can do it. Indeed, that's what we did. We have this application, the exact same application, exact same code that runs on two different platforms. One is Google App Engine, and the other one is a proprietary platform that we built for ourselves. And one is using jQuery, and the other one is using Super Agent. Yeah.
Has each UI its own store and API adapter?
Yeah, exactly. So no, actually, the API adapter is the same in our case. What's changing is the wrapper of the API. So I'm going to show you some code about this. So yeah, you have another question?
Sorry, this picture. Way. Oh. Here is.
No. Okay, so no. Okay, so that's a good question. The dispatcher is only the reason why events can get to their destination. But the fact that he wants to send an event and he wants to listen to that event is totally orthogonal. So the dispatcher is responsible for delivering this save changes event from here to here, action from here to here, as well as this one from here to here. But nothing prevents you from having different components listening to. It doesn't having a single dispatcher, and that's the reason why I don't like that picture initially, because it seems like your stores are the only ones who are eligible to receive actions. That's not true. That's not true. Well, no. It's you can receive actions in any place of the code where you register to the dispatcher, so that you can receive an action. It doesn't have to be stores.
You should only register the stores.
No. No.
Okay.
Yeah.
I've heard there are like multiple Flux architectures.
There's okay. To be honest, yeah. I mean, everyone came up with their own version of the architecture. So it's really not like. In fact, the documentation is not even too clear about this. But if there was an interesting panel discussion in the conference about Flux. And they were talking about different things among also this one also among those. And as I said, they call it action creators. So people in Netflix, I think, and a lot of people, most of the people, do their network writes in the action creators, and almost no one wants to do networking in a store, but someone does, but only for reads. So if you have a store that does a caching layer, then and so the UI already knows that when they ask for a piece of data, maybe it's not ready yet. So then in that case, it makes it easier to have the fetches from the server in the store. But everyone agrees on the fact that the network writes should be done in the action creators. Now, I want to depict the picture in this way, and I want to make a different box here But if you look at the code of how they write the code, and you look at mine, it's probably going to be the same. It's just the way that I like to draw this picture. But the important thing is that you keep the write separate from where you keep the store. The show dialog true is when someone clicks. The dialog is not shown yet, and someone clicks on edit detail, so you have the dialog.
Okay, so this is store listening.
Is store listening to an action.
Okay.
To an action. Yeah, it's a different action. So yeah, the API can be replaced, as I just said, and also the UI now can be replaced because we have React Native. So let me show you some code. Okay, this is, as I said, my own version of events and actions. I don't particularly like the stock implementation that comes with the default Flux implementation. So I basically built a little wrapper around them so that it's more convenient for me to create actions and events. And this is the way you create events. You just list their names, and they're namespaced so that I can turn on debugging and I see them printed on the console nicely. And the same goes for actions, but I can specify in actions, I can specify what kind of parameters I want to pass, so that maybe I want to be fancy and I can do some type checking. But this is nothing new under the sun. So let's look at the UI. So we have a parent component that, as I said, checks on the store, checks if the dialog has to be shown. And the store, as you can see, is something that's being injected as a property in the component. I like to so there's people using the stores as singletons, and people like to like me. People like to have them as instances that are passed inside the components. So this is a little bit more verbose, but it's more flexible. And then, well, this is the dialog. And if the dialog is not shown, then you just have the UI without the dialog. And the dialog, this is the dialog. So I'm gonna make it slightly smaller, otherwise you don't see it. So if there's an error on the store, then you format it as a piece of DOM, and then you put it here, and then this is the spinner, and then this is how you dismiss the dialog. You just fire the action on the cancel button. Otherwise, if you want to save the changes, you hook it up to this function that somehow collects data from your form, and then just fires this other action. So far, so clear? Okay, so far, so. This is the API adapter. So the way I initialize it is via function, so that I can actually inject the store and the network API. There are the two ends of the dialog and of the diagram. And so my API adapter listens to the save changes action, and fires this other action for set processing. Then uses the network API with data that is partially from the store and partially from the payload of the action, and then waits for the response, and then calls a method on the store. Now this is a little bit controversial. You may or may not want to actually go into the store and change the data from here. You may want to fire an action instead. But there's pros and cons about that. And then you have the dismiss dialog and the set processing to false, or the set error and set processing to false in either case. Now the network API in this case is a jQuery wrapping, a very simple wrapping. So you create a deferred, and then you fire the AJAX call, and then you resolve the defer, or you reject the deferred. And this is the store. So it's a class, as I said, nothing fancy. That's initialized somehow. We'll see how. And then it stores this internal state, and then listens to some actions and changes, the appropriate bits of information according to the appropriate actions. And then this is the method that I was using before for changing the user details. every time you change something inside the store, then you have to fire an event so that the UI can update itself. And that's it. So this is the way you bootstrap the application. So you initialize the store, and this may be stuff that comes dehydrated from the server, or maybe it's some hard-coded value. You know it. And this is how you initialize the API adapter, because you pass it the store and then the specific implementation of the network API. You may have different wrappings, as I said. And now you render the React component by passing in the store. So any question about the code so far? All right.
Do you have to manually pass the store to your child?
In this case, yes. In this case, yes. I mean, well, either you pass from component to component by writing store equals store every time, or you just use inherit from, what's the syntax? Well, there's a syntax for if you have to pass more stuff, there's a syntax to simplify the passing properties down. But yeah, this is the thing that I was talking about before. So I like to pass the stores explicitly via props, so it makes my code a little bit more verbose. Some people like instead to have stores as singletons, so they're available in the namespace, and you don't have to actually pollute your component with properties. But it's this way it's easier to test, because then with tests you can create a store in every fixture. You can create a new store and feed it into the component, so you don't have to actually mock them and or implement maybe reinitialization of the same store from test to test. So there's pros and cons. You can have as many stores as you want. Indeed, we have a couple of different stores. Depends on how you want to structure your application. So, for example, one good example that they gave at the conference was about an application that does email. So you may want to have a store that contains all of the messages, the email messages, and a store that contains the threads. And the thread objects inside the store, the thread store, will reference just have a reference by ID to the email. So it's good to have different stores sometimes. Yeah, absolutely. Yeah. This example was just a very stupid one. Yeah, absolutely. Yeah. So you may namespace those Boolean variables, and so when you say show dialog, you say which dialog you want to show, maybe, or maybe you use different stores. So yeah, depends on how you want to do it, of course. But if you do have different stores, then you run into the problem of synchronizing them upon receiving actions. So that's one of the reasons why you have the wait for in the default implementation of the dispatcher in the Facebook implementation. So if like both the email store and the thread store listen to the same action, and both need to update, maybe you want to give the email store a precedence over the thread store, because maybe the thread store will require the emails to be in the store already when it comes to its turn to update itself. So you need to have some synchronization mechanism, and the wait for is exactly for that. So yeah, so the advantages of having a separate API adapter module is that it's a really good place to write the little code that is needed for marking in progress and having spinners. It's also a very nice place to capture and format the error messages. You get an error message from the server. Maybe you want to format the string as error message column space and then the actual message and dots at the end. That's a nice place to put it, so that when you get to the store, it's already clean. And you also want to normalize network results sometimes. So in the example of the email application, you may have a specialized API call from the server that returns the whole bundle, like thread, including the messages. But if you have multiple stores, you have to normalize that response. So you get one JSON from the server, but you want to chop it down into different messages, and you want to feed them separately to the stores. that's a good place. Having a separate API adapter or action creator, call it the way you like, is a good place for this kind of code. And then it's also a good place for doing optimistic updates. So maybe you want to, server will answer in 3 seconds, and you want to update UI anyway optimistically. And then maybe if something goes wrong, you just display an error message and roll back. So that's also a good place to do optimistic updates. Speaking of which, I thought it was an interesting little idea. So I made a little slide about how to implement optimistic updates using stores. So if this is your store, the state that's internal to the store is what I would call the durable store. And when a network request is fired, when you fire the request, you also add something on top of it. So you keep a stack of frames with just the change data. And you stack it on top so that when the UI reads the store, you first check if that data is in the frame that's temporarily being stacked on top of the other one. If it's not here, then you can check the durable state. But if it's here, then the client sees the updated state, the optimistically updated state. But if the server comes back with an error, then you just destroy this stack, and the visible state, the state that's visible from the outside will naturally go back to what it was before because we have removed a frame. And then if something else some other request goes well, then when it comes back an OK, then you feed it into the state and you merge it. And so you've actually done the update. This is what they've implemented in Relay. And so I thought it was a cool idea, and I made a slide of it.
So I have multiple frames like that?
You may have multiple
requests?
frames. Yeah, I think so.
Well,
I think so.
They're supposed to run one. Otherwise, you cannot.
I'm not entirely sure. I just took it up like Yan Chen was talking about this.
Because
And
then if you have like 5 requests and one of them fails, you probably have to drop them all because it will be difficult to merge.
yeah, if they're yeah, I see what you're saying.
I
Yeah,
understood that they were serial. So
You
it's
probably-
one after another.
yeah, you probably
There's
don't
always
want to
one
do
thing in the
that.
loop, because otherwise you cannot use a stack.
Right.
They're-
You probably don't want to. You want to query the same resource more than once before having a response. Otherwise, it's going to be tricky. But yeah, I thought it was a cool idea, so I made a slide out of it. The other very cool thing that I've been talking about in the conference was Relay in GraphQL, and somebody said, "Yeah, can you talk about it?" So I knew nothing about it. But this is all I could come up with. So if you guys haven't seen the video, it's been presented at the conference a few weeks ago, and it's for the first time it's a piece of software that starts to smell like a framework. Whereas I like to think of React.js as a library, because this is a big thing, is a big piece of code, and like they say, it's for big apps and big teams, very specific solution. I would say it's very specific, probably to Facebook at this point, but it's not out yet. So we don't really know what it will look like in the end. So it's probably very cool and worth check it out when it's out. But it's basically a way, just in 2 words, from what I understood from the video. It's a way to describe GraphQL is a language to describe JSON structure, and each component is provided with a description of the kind of data that it needs to have in order to render, and you don't have stores anymore. Because there's one store that's provided by the library that does it all for you. All you need to do is feed the system with the description of the data that you need, and the system will fetch it for you from the server. And if you need, data that is structured in a given way, then you'll get data that is structured in that way, because you're basically describing the form of the interaction. But I assume you'll have to have a server side that will, match exactly what you're describing. So I don't know. We'll have to see what it looks like. So I guess this was it. If you have questions, or this is the list of topics that I'm interested in. So we can talk about pretty much anything. But if you have questions specifically.